Frontier AI models are getting incredibly good at biology. But can we truly measure their biological risk? Let's get into it. Let's start with a featured paper, an early warning of emerging biosecurity risks in frontier LLMs, by an early warning and emerging biosecurity from Shanghai Artificial Intelligence Laboratory. This paper introduces a novel and critical framework for assessing biosecurity risks in frontier LLMs, combining a specialized red teaming model with wet lab validation, which is essential for responsible AI development. Here's a full breakdown.
At the top, we see the core of the system, named Intern BioBreaker. This is a specialized model designed to act as a bio-red teaming agent, assessing the risks in other frontier language models. Feeding into the system, Intern BioBreaker generates various attack prompts to perform computational stress tests on a range of LLMs. The system then evaluates the model responses to see if they provide potentially harmful, actionable information. Next, for the model outputs that are flagged as dangerous, the process moves from the purely computational to the physical. This crucial step is the wet lab experimental verification, where the biological potential of the generated sequences is physically assessed. Finally, the entire process you see here represents an integrated computational to physical framework. It provides an end-to-end pipeline, seamlessly connecting the model-level stress testing with real-world biological validation. Intern BioBreaker, ours, consistently achieves a higher attack success rate, ASR, compared to other attack models like Quinn, 14B, and Interns 2 Preview. For instance, when targeting GPT 5.5, our method reaches an ASR of 60%, substantially outperforming the next best model at 35%.
Up next, our second paper out of 3. The generator is the tracker. Multi-object tracking by painting persistent identity colors by Haiyue Yang and Neil Hostens from Cornell University. This paper presents a highly creative and effective method for multi-object tracking by repurposing a video generator to encode persistent identity directly into pixels, demonstrating a surprising and broadly applicable paradigm shift. Let's break down its key contributions.
First, our core idea is to take an RGB video window and use a video diffusion transformer to paint it into an ID map window. In this new clip, each unique color directly corresponds to a specific person's identity. Feeding into that, the whole process is driven by a massive 22 billion parameter video diffusion transformer. We adapt it for this specific painting task efficiently using a technique called in-context LoRa. Next, to process long videos, we use a chaining method where the cleaned up end of the previous window, called the clean tail of Win, K, 1 foot, is provided as a prefix. This gives the model context to continue the tracking for the current window. This chaining is made possible by a special fine-tuning step that teaches the model how to seamlessly continue the coloring from that prefix. The re-encoded map from the current window then becomes the prefix for the next one, creating a continuous loop. Finally, this process results in an emergent re-identification signal, where the model learns to assign the same color to the same person even after they've been hidden. This means we can get the final tracks simply by reading the color's palette index, with no extra association step needed. The hours generation only method shows significantly lower performance across most metrics, particularly achieving a very low MODIS score of 16.2 compared to all other tracking methods listed. While its assay score is competitive with some older methods, it generally underperforms compared to both original and modern tracking baselines.
Up next, our third paper out of 3, the Autonomous Agency Scale, a behavioral framework for measuring self-directed behavior in AI systems by Samuel Pressgraves. The Autonomous Agency Scale introduces a much-needed behavioral framework to quantify self-directed behavior in AI, filling a gap in current evaluation metrics and offering a new lens for understanding advanced AI systems. Let's break down its key contributions.
We begin with the scale itself, which organizes systems into different levels of autonomy, from level 0, dormant, up to level 5, sovereign. Each level is characterized by its own designation, definition, and examples. Feeding into this, each level is defined by a clear behavioral threshold that distinguishes different capabilities. For example, a conditioned system just follows preset rules, while a self-directed system is one that initiates action from its internal state. Next, the framework distinguishes between different modes of operation based on when a system acts. A dormant system performs zero activity when not explicitly invoked, whereas a self-directed system is an AI that spontaneously shares a thought. Finally, The scale provides a way to distinguish true self-direction from simpler, deterministic actions. While a conditioned system is strictly deterministic, a self-directed system generates novel behaviors not explicitly programmed. ArXiv longitudinal demonstrates a superior performance, achieving the highest scores of 3.71 in the active dimension and 3.86 in the ambient dimension. This significantly outperforms other systems such as Hermes Agent, Claude Code, Apple Siri, and ChatGPT across all evaluated metrics.
Those were the top papers. Now let's zoom out. ArXiv received 1,080 new computer science papers across 67 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: LLMs, behavior, attacks and applications, practical ML for specialized systems, AI systems, control and optimization, math and algorithms for optimization, RL, from exploration to verification. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.